Welcome to The Explainer. Today, we're going to do something a little different. We're taking a whole folder packed with code, and we're going to turn it into a story that actually makes sense. We all use apps every single day, right? But what's really going on behind the screen? Well, today, we've got our hands on a collection of files from a real live software project. And we're going on a little tour to see what story they tell. And trust me, it's a journey. We're going to go from the huge, grand plan all the way down to a single, tiny, problematic emoji. Okay, so when you first look at a folder full of code, it can be a little intimidating, let's be honest. So where do you even begin? Well, think about it like building a house. You always start with the blueprint. And this house analogy, it's going to be our guide for today. So the architecture, that's the big picture blueprint. The front end, well, that's all the stuff you see and touch. The interior design, the paint colors, the furniture. And the back end, oh, that's all the critical stuff hidden inside the walls. The plumbing, the electricity, the things that actually make the house work. It's a great way to think about how all these different software pieces are supposed to fit together. Okay, so let's jump right into this project's master plan, the blueprint. We found it laid out in the documentation files. This is where we get to see the real big picture. So it turns out this project uses a really cool modern approach called agentic architecture. Now, what does that mean? Instead of building one giant clunky program, the whole thing is broken down into smaller, smarter pieces. Kind of like a team of specialists, right? You've got these agents who are experts at specific jobs, and they use a library of reusable skills to get things done. This makes the whole system way more flexible and a lot easier to update. It's a pretty slick way to build things. Now, to keep all those different parts from getting messy, everything lives in what's called a monorepo. And that's really just a fancy way of saying it's all in one single master folder that holds the entire project. And as you can see, everything has its designated spot. You've got a folder for the front end, a folder for the back end, and even separate folders for all those agent skills we just talked about. It's kind of like a perfectly organized digital filing cabinet. All right, so we've seen the blueprint. Now let's step inside the house. We're going to look at the part that everyone actually sees and interacts with. The interior design, the paint, the furniture. In the software world, we call this the front end. So what is this app? It's actually a pretty straightforward to-do list, something we've all probably used a million times. The plans show it's got all the features you'd expect, and it's built with some really popular modern tools, Next.js and TypeScript, which basically help developers create these really slick and reliable user interfaces. Plus, it's designed to work on any device, and it even saves your tasks right there in your browser. Pretty cool. And this next part just shows you the incredible level of detail that goes into a project like this. Seriously, it's not just about what the app does, it's also about how it feels. The plan actually specifies the exact color palette. It's got this whole brown and yellow theme going on to create a unique visual identity. And I mean every single color, right down to the specific shade of red for the delete button, was chosen on purpose. Okay, so we've seen the pretty interior. Now, let's go behind the walls. It's time to check out the hidden machinery that makes this whole thing tick, the back-end engine. This is the plumbing and electricity of our digital house. Right, so if the front end is what you see, the back end is the powerful engine running under the hood. It's actually a totally separate program, a server, that the app on your phone or computer talks to. And this server handles all the really important stuff, your data, your user account, and all the complex logic you never even see. The docs also have super detailed instructions for developers on how to get this engine up and running. And yeah, looking at all those raw commands might seem a little intimidating at first, but when you really break it down, it's basically just 4 steps. You open up a terminal, you go to the right folder, you install the tools you need, and then you start the server. That's the gist of it. Now, one of the most critical jobs for this backend engine is, of course, security. You can think of it like the bouncer at the door of a club. Before you can get in and see your to-do list, you have to log in and prove who you are. This whole process is called authentication. So how does the server keep track of who you are after you've logged in? Well, it uses something called a JWT, which stands for JSON Web Token. The easiest way to think about this is like a secure temporary digital passport. The moment you log in, the server hands this passport to your browser. Then for everything else you do, your browser just flashes this passport to the server to prove, hey, I'm allowed to be here. We actually found an example of one of these tokens in the project files. But, building software isn't always a smooth ride from blueprint to finished house. Not at all. So now let's talk about the, let's say, less glamorous side of things. The absolutely essential reality of troubleshooting and fixing things when they inevitably break. Yep, we're talking about bugs. I'm telling you, every single developer on this planet knows this feeling of pure frustration. You spend hours, maybe days, building something. You go to test it, you click the button, and you're hit with a super cryptic, totally unhelpful error like this one. Fail to fetch. What does that even mean? It basically just tells you something somewhere is broken between the front end and the back end. So we dug into the project's troubleshooting notes, and it reads like a classic detective story. The developer checked everything. Is the server even on? Is the network okay? And after all that, they finally found the root cause. It was a single setting in the command they used to start the server. This little -reload flag was causing all kinds of internal errors. And the solution? Just take it out. A super simple but absolutely critical fix. But the next bug they found, oh, this one is even more surprising. The developer ran into this totally bizarre error, a Unicode encode error. Now, all that means is that the computer basically choked on a specific character it was trying to process. So you have to wonder, right? What kind of character could possibly be powerful enough to bring an entire program crashing to its knees? This. This is the line of code that caused the crash. That's it. The whole script was failing because the system, on this particular computer, could not process a single rocket ship emoji in a simple printout message. An emoji! I mean, come on. It is the perfect example of how the absolute smallest, tiniest detail can have huge, unexpected consequences. So here's the real takeaway from all this. Digging through these project files, it becomes so clear that a working app is so much more than just lines of code. It's a high-level architecture. It's a carefully designed interface, and it's this relentless, continuous cycle of human problem solving. From that huge, grand blueprint all the way down to a single tiny emoji, every single detail matters. So the next time you open an app and tap a button, just take a second to remember the hidden world behind it. Remember, there's a whole architectural plan. There's a very specific shade of yellow that someone picked out. There's a little digital passport keeping your data secure. And maybe, just maybe, there's a developer out there who spent an entire afternoon fighting with a rogue emoji. There's a whole story hidden inside every folder of code. Thanks for digging into this one with us.